This is part 3 of section 3.1. We've been talking about quadratic functions. And one thing that we often talk about are maximum values and minimum values. We're going to be getting a lot more into this later. The plural for maximum is maxima. The plural for minimum is minima. Okay? And one of the things we're going to be worried about often when it comes to using these things in the real world is whether or not something has a maximum value or a minimum value. Like we might have a formula that represents the area of a yard that we need to fence in. We have a certain amount of fencing. We're going to maximize the area. Those kinds of real world situations are useful. Now, the good thing is that we will always, when we're talking about a quadratic, we will either have a maximum or minimum at the vertex, okay? Now, you could go through and you can memorize all of this, or you can just connect it with something else and use a little bit of logic. If my a value is greater than 0, what we knew was that this means our graph opens up. Well, if our graph opens up, do we have a maximum value? No, these continue forever. It has a minimum value if our graph opens up. If our a value is negative, then our graph opens down. Does this have a minimum value? No, it extends down in both directions, but it does have a maximum, which is at the vertex. Okay? Now you're going to be asked to find the value and determine where it occurs. Where is always your x value, and the value is always your y value. So we would say if our vertex was -2, 3, and our graph opened down, then we would have a maximum value. We would have a maximum. Where is it? At -2, and what is the maximum value? 3. Okay. So, without graphing, determine whether the function has a maximum or a minimum value. Find the value and determine where it occurs. Okay, well, our a value for this one, f of x equals -2x squared minus 12x plus 3. Our a is -2, our b is -12, and our c is 3. Okay, so my a value is negative. That means my graph opens down. Therefore, I will have a maximum. Okay, so we have a maximum at with value blank. Okay, now we just need to find the vertex. If we can find the vertex, then we have both of these. To find the vertex, we need -b over 2a. So this would be -12, which is +12, over 2 times -2. So I have 12 divided by -4, which is -3. So we have a maximum at x equal -3. With value, and this is going to happen at y, we need to take this and we need to plug it in here. So we need to find f of -3. So this is -2 times -3 squared minus 12 times -3 plus 3, which is -2 times 9 plus 36 plus 3, -18 plus 36 plus 3 is 21. So the value is 21. So we know, even though we haven't done our graph, we know it reaches a peak when x is -3 and it reaches the maximum value of 21. Okay? So let's repeat that here. For f of x equals 6x squared plus or minus 6x, and this is always a plus 0. If you have a missing piece, you can imagine the 0 in there. So in this case, Our A value is 6, our B value is -6, and our C value, if we should need it, is 0. Okay, my A value is positive, so it opens up, which means I have a minimum. And it happens at whatever our X value is, and it has the value whatever our Y value is. So let's find -B over 2A. So this will be -6, +6, over 2 times 6, which is 6 over 12, which is 1/2. So I have a minimum at value X equal to 1/2. Now we just need to figure out what that is. Okay, so we need to find F of 1/2, which is 6 times 1/2 squared, which would be 1/4, minus 6 times 1/2. 6/4, which is 3/2, minus, well, I'll just leave that as 6/2, so I don't have to find a common denominator. And then 3 minus 6 would be -3/2. So our value is Y equals -3/2. Okay, now this is the official end of the lecture, but I am going to add another one that shows you where the -B over 2A formula comes from.